Hi there, hires. Welcome to your fifth video in this sequence. We're looking at program A5 or problem A5. Now, problem A5 is again looking at 2's complement, but now we're pulling everything together. So we are going to be creating a computer program which accepts a number between minus 127 and positive 127, and then displays the relevant binary sequence. If it's a positive number, it displays just a normal 8-bit binary sequence. And if it's a negative number, it displays the relevant 2's complement 8-bit binary sequence. You should use all of your code from previous examples, sort of put it together. It's not actually that tricky. But if you'd started with that, if that had been the first challenge, you would have found this quite tricky. So hopefully by breaking it down into 5 different programs, you can see how much your programming has improved and how you've been able to solve this problem, hopefully in a much shorter program than maybe you would have had at the very start. So we're going to take our 7 steps. And again, we're going to code this in a NAT5 style, so no subroutines, no data flow between each one. That's coming in a future lesson. Okay, so I'm going to take this, I'm going to copy and paste it into the Replit right now. So we're looking at the Replit now for A5, and I've copied and pasted the design in just so we've got these kind of steps to refer to. It's always good to have the program design in your code if you can, because then it's very easy for someone marking it to see that you've described each step that you're coding, and it also keeps you right. Good thing about this one is there's no sub steps, so unlike A4 where I got my indentation wrong, there shouldn't be any issues this time. Let's hope. So getting a denary number between negative 127 and positive 127. Just as before, you're just asking for the user to enter a number between negative 127 and positive 127. Okay, I'm just going to put in a little space there after the colon, just because if I don't, it slightly annoys me. And remember, we've got our input validation. So we're saying while denary is less than negative 127 or denary is greater than positive 127, we're going to display an error message. Okay, and then we are going to just ask the same question again. Okay, by the time we get to line 6, we should definitely have a value that's between negative 127 or positive 127. And if we don't, then it's probably my indentations again. Okay, now step number 2 in our code is just to check what the denary number is. Okay, so before we do any conversion, we're just going to check this out. So we're going to say if denary is greater than or equal to 0, then we're going to calculate the 8-bit binary sequence. Okay, so we'll do that in a second. I'm just going to put in a little print for now. Okay, calculate positive. Okay, and else, it's just else. And then we're going to calculate negative, or I'll just put 2c. So calculate 2c. There's no end ifs in Python, so we just tab back and then outputting the binary sequence. Well, when we generate it, we will output it, okay? So let's just run this code to see if our logic works so far. What we're looking for is to make sure that we can type in a number that is between negative 127 and a positive 127. So I'm going to start with 0. Okay, so 0 says calculate positive, which is correct. Okay, we're going to do minus 42. It should say calculate 2's complement, which is correct. And I'm going to check 42, just say calculate positive, so that's correct. I'm going to go beyond, so I'm going to say 999. So that's outside the range of numbers, so we should get an error. We get an error. Try again. Always test that second time, so just in case it's an if statement. Okay, so it says try again. I'm going to say minus 888, error, 777, minus 666, and so on. And 111 should work. Yeah, so 111's positive. So that's good. So we've kind of checked our input validation works, and there doesn't seem to be any logic errors there. It displays the correct message. If it's over 0 or equal to or over 0, it says calculate positive. Otherwise, it says calculate 2's complement. So I'm happy with our logic. Now our next step is to replace this placeholder with calculating the 8-bit binary sequence. So let's just call our binary output binary. And remember, we've got our denary number, so you can say denary, comma 2, or int denary, comma 2. So that generates, this is nonsense, sorry. That generates the denary value from the binary. So we'll do it the proper way because we've got the denary. So we're going to format the denary into 08B, okay, format, which puts it into 8 bits. So that should be all we need to do there. Excellent. And the 2's complement, well, we need to go back to our step, or our steps in task A3 or in A4, if that's easier. But essentially what we did was this. I'm just going to code it, so design it, sorry. So we work out the positive binary. Okay, we flip 0s to 1 and 1s to 0. And then 5.3 is we add 1 to binary. Okay, and that will calculate the 2's complement 8-bit binary sequence. So we'll work out the positive binary, remember, so we've got pos binary, pos denary being equal to the absolute value of denary, okay, which we typed in earlier. So if we typed in minus 42, it changes that to positive 42. We are then going to work out the positive binary, just using the same as before. So it's format pos denary, comma 08B as the mask or the format. So that gives us our positive binary value for, say, if we enter negative 42, it will calculate the positive 42. We're then going to flip all the 1s to 0s and the 0s to 1s. So if you remember from the last video, we're looping for index and range 0 to 8. And then we just treat, sorry, Replic's giving me too many help things. We take the index position of the binary, and we say if that is equal to 1, then we're going to say that the new output is plus equal to 0. Otherwise, it's definitely 1, so new output would be plus equal to 1. Now, it's underlined new output because new output doesn't exist yet because I forgot to add it in to here and set it up to be blank. Okay, so you always have to have that blank variable ready to go, otherwise plus equal doesn't work. So if the binary at position 0, 1, 2, 3, if you remember this booklet from earlier, so that's position 0 of the string, that's position 1 of the string, that would be position 2 of the string, 3, 4, 5, 6, etc. If it's equal to 1, then our new binary, the flipped binary, is equal to should be 0, otherwise it's 1. Okay, so by the time we get to line 24, where I am just now, we've got new output, and new output is the binary sequence which has been flipped from the positive binary sequence. We just have to remember to add 1 to the binary. So what we do is we say we'll call it final denary is equal to the integer value. This is the right one this time, of new output, comma 2 plus 1. Okay, because we're adding that 1 to the binary. And so our final binary, which I'm just going to call binary, is equal to the format of final denary, comma 08B. Okay, so we've got our mask there, or our format again there. There's nothing in endif, there's nothing in Python for an endif, so we just tab back to the main so to the first line, and then we output the binary sequence. Now, notice that in both the if statements, I create a variable called binary, okay, line 26 and line 10. So I know that the correct binary sequence is just in a variable called binary. So I'm just going to print binary, okay. In this example, I'm not showing sort of breakdown at the moment. So just to show you there's a difference between the two, I'm just going to print them out now. So I'm going to say pause, putting an extra space in. I'll explain why in a second. So pause binary, and I'll copy that down there. And we've got our flipped one there, which is called new output. Okay, so we've got flip there, and then we've got our final denary, which will then be output at the end. Okay, so let's run that and see what has happened. Okay, so here we go. Enter a number between 127 and negative 127. Okay, still error. Sort of the range check still working. So I'm going to go for minus 42. So let's see what happens. So it does the 2's complement. We can see that's happening. So it works at the positive 42, which is 16 plus 8 plus 2, which is right. Is that right? No, sorry, 32 plus 8 plus 2. That's better. And then we flip it. So the zeros become ones, the ones become zeros. And then we add 1 to the flip. So just highlighting the last 2 bits of the flip. If we add 1 to 0, 1, it becomes 1, 0, like that. Okay, so 1 plus 1 is 2. So we've got that and it seems to work. So let's just test it with 42 and see if we get the correct binary output. So that's 32 plus 8 plus 2. So it works. So what we've done in our program for A5 is we've taken all the things we've learned about 2's complement, but we're also applying it to the range of numbers that can be generated in 2's complement. Remember the first bit, the one on the left-hand side of the 8 bits, if it's a 0, it's positive. If it's a 1, it's a negative number, okay? And that's how we can sort of visually tell the difference between a positive number and a negative number when it's in 2's complement. The whole range of numbers should total 256 different numbers, and I can see there that maybe we haven't got all that, and I've said that I would test it and check it, and I never did, but it was in one of the SQA questions this year. So I'm just going to do positive 127 just to show you what would happen. So there we go. So that's the highest positive number that we can get, because all the ones, so the 7 bits that are all ones, are obviously sort of representing 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. But we can't change the 8th bit to a 1 because that would make it a negative number. So let's see what happens when we do minus 127 and see if there's any scope for extra numbers. So maybe. So what we've got here is we've got the positive version of 127, which is 0 and then 7 ones. We flip it so that we have 1 and then 7 zeros, and then we add 1, which means that we've got 1 and then 6 zeros and then a 1. Let's just check. I think that's the lowest value we can go, but I suppose technically we could have 1 and then 7 zeros after we add the 1, but how do you get that? That's the tricky part. So what we really need to do is to have, after the flip, when we're flipped it, 0 and 7 ones, and then by adding 1, it becomes correct. So if we had 128, flipping it would do that. So let's just change that code. I knew it was just slightly out. So I'm just going to change the code there, change the number there. Oh, sorry, it should be the negative, not the positive. Oops, pressing the wrong button there. So minus 128 to positive 127. And then I'll just change that as well. It's just text, but I'll change it anyway. Right. And if we run the program one more time, okay, and we put in minus 128, and let's see what happens. So minus 128, so 128 positive is 1 and then 7 zeros. So we flip it and it becomes 0 and 7 ones. But then because we add 1, it carries all the way along and creates this 1 on the 8th bit, or the leftmost bit of the 8. And that means it's a negative number. And if that's a negative number, then the rest, the 7 zeros represent negative 128. So that works. So if you're ever asked what is the range of numbers available in 2's complement, because it should add up to 256, you've got minus 128 all the way up to positive 127. And hopefully that, now that we got to that point, that's shown you how easy it is to check that, okay, and then adapt your program. Okay, if you've got any questions about that, please do post in the comments on YouTube or post in the comments on Google Classroom. I hope this has been useful. Speak to you soon.